Hello, good morning, good afternoon, good evening, good night, wherever you are in the world. Welcome to runZero Hour, episode 9, which is really exciting because now I don't know if the next episode is going to be episode A or 10 or 16. So we're going to find out. That's going to be fun. I am joined today by HD Moore, who is the founder and CEO of runZero, and Blaine Smith, who is a senior security researcher here. Welcome, gentlemen.
Glad to
This
be here.
this edition of runZero Hour is a very special edition where we're going to talk about all things SSH. It's been a banner year, pun intended, for SSH, and we're going to talk about some interesting reads, like a crime novel, going hunting on the internet, and the things that we found. And with that, I'm going to let HD talk about the the big news of the year and how it kicked off this wonderful adventure. So HD.
Sure. Rob and I were having a lovely Thursday afternoon, as many will, and then saw the note about the XUtils backdoor being discovered. And that kicked off a very long weekend of trying to figure out how do you detect it, what did it affect, how do we detect affected machines, all that fun stuff. So for folks who weren't following the campaign, it was effectively a very long multi-year social engineering campaign in the open source community to take over a project that's used by a lot of important packages, introduce a backdoor that only affected SSH running on Debian and RHEL-based distros, and do it in a way where the backdoor is only accessible to the attacker. So most of the stuff where a typical nation state kind of model where you only create a backdoor that only you can exploit, basically using a public-private key. I was caught the last possible moment by Anders Frund, where he noticed that SSHD was using a little more CPU than it should have, and then figured out that, hey, this thing's actually backdoored, and put a stop to it prior to it rolling out to all the beta and stable distros. So effectively, the backdoor only really made it into the rolling releases, but that was enough to spin up the whole operations response side here at runZero. So that kind of kicked off kind of the research. And so what we thought would be fun is like, okay, so there's this threat actor that went by the handle Giatan, had a GitHub account that was part of this whole backdoor process. Like, can we actually find this Giatan person? Like, where are they? Are they located like in the US? Can we figure out what machines they've had access to? So we started digging around a little bit and trying to figure out like how do we figure out who this person is and where the attack came from. So that kind of leads us to this process of going hunting. So Giatan or whoever the folks are behind this handle, they targeted SSH using the XUtils backdoor. We thought it'd be appropriate to then target Giatan using SSH. And there's some really neat tricks that we're going to go into about how we went and did that. So a tangent. When you do SSH authentication, um, through a public key, there's actually two phases to it. First, you ask the server, would you accept this public key? And you do that by presenting the public key, the public part of the public key to the server. If the server says yes, then you use your private half of the key to sign a blob of data saying that, yes, I control the private key. And it also ties that authentication to the negotiated Divi-Hellman session or whatever the negotiation session ID is of the transport. So it kind of locks everything together and says, yes, I'm proving who I am and who I'm talking to as part of it. However, there's a really fun trick you can do, which is if you have someone else's public keys, you can ask a server whether they accept those keys or not. And if you have a large database of keys, you can test to see whether a server accepts any of those keys, or if you have one key in a lot of servers, you can see which of the servers accept the key. So it's kind of a small information leak in kind of an S8 protocol. It's been there forever. There's a Metasploit module since 2012, which is a lot of fun to play with. But no one really knows or uses this because there wasn't really a good reason to, to really do much with it before. However, now we have one, which is how do we go find Giatan? So we built a little tool that we called Shamble at the time that uses a mangled version of the Go standard library xcrypto.sh stack and then modifies all kinds of stuff to do terrible things. And we use that to create a half authentication pub key scanner. So very similar to the Metasploit module, but a lot faster in this case because we wanted to throw it at the whole internet. So we pulled the Giatan keys from GitHub. We wrote this code. We ran Zmap. We figured out all the machines with what ports were open. And effectively, we threw it at the whole internet to see could we authenticate to any server on the internet using Giatan's keys. And the idea was that if we find a server that says, yes, I accept this pub key for authentication, we know that's a system that this person or actor would have had access to, and therefore we can help identify who they were and what they're doing. So yeah, that was the idea. So we get the pub keys from GitHub, we scan all of IPv4 for port 22, and then we try like some common usernames like root admin Giatan 575 or T75 things like that across all these servers, only doing the half authentication. So not even completing the full authentication handshake, but just that very first part of do you accept the key or not. And so surprisingly enough, we got results, but unfortunately we got lots of results. The process of scanning it took, in between like 4 hours to 12 hours, depending on how many CPUs we threw at it. And it made our poor little droplet very unhappy while we did this because all those SSH handshakes are pretty CPU intensive. So kind of a first clarification is, even though we were just looking for what servers accept the key, the process of testing out the key resulted in GTAN's public key hash tied to our IP addresses and everyone else's logs. So it looks like if you're investigating the GTAN backdoor for executils and it looks like it's coming from us, it was not us. We are just scanning for the key. So please don't arrest us. But now getting into the results a little bit, we found a bunch of honeypots, a bunch of broken servers. We found systems where every third key attempt they would accept no matter what, even if the key wasn't valid. We found machines with like corrupted memory, where some keys were accepted when they shouldn't have been. So we fixed the bugs, added like false positive testing, rescanned, repeat. Didn't really sleep much that weekend, and we found nothing. We found no system that we could possibly confirm as being a GTAN allowed authentication with that key set from GitHub. So that was sad. We didn't really find much there that was helpful for this whole project. But then we started looking at the data we actually got back instead, and we found like 110,000 shells. We're like, well, okay, well, we didn't find this. We found a bunch of other bugs. So that kind of led us down the path of doing a lot more research into the SSH ecosystem, and that kind of sets things up for the actual presentation. So, we talked a little bit about public keys. It used to be that a public key was, even though it's called a public key, it's not something you typically shared, at least your SSH public keys. You didn't necessarily put them on a website and let people have access to them because really the only, you know, machine that needs access to your public key is the SSH server you're connected to. However, both GitHub and Launchpad.net have changed that. They started using SSH keys as public identities. So if you've installed a recent version of a Ubuntu server recently, you'll see that during the installation process, it'll ask you if you want to import your SSH key from GitHub or Launchpad. It's like, oh yeah, sure, pop your username and it'll grab your key and set it up on the server, and you don't have to like set up your configuration and make your life easier. You don't have to worry about your machine getting popped through a weak password during setup because it's key based off. So really neat way to do that. However, some other folks found that you can just take all the keys from GitHub, build the giant database, and use that to de-anonymize people who connect to you. So if you connect to Filippo's server here, SSH to whoami Filippo.io, it'll actually do a reverse lookup of the pub key you sent against the GitHub database and say, oh, you're HD or oh, you're Rob, depending on what key you present. So it's kind of a neat process, little neat kind of trick in the protocol, but it's also what we're using for this hunting process. So putting all this together, there's really three components you need to do kind of a mass key hunt on the internet. So if you know somebody's public key, you can get that from GitHub, Launchpad, or look for one of these weak compromised keys from the Bad Keys project. You need a list of all the servers on the internet running SSH. You can grab that passively out of things like Shodan, Census, or just do a quick scan through Nmap, Zmap, Masscan, your tool of choice. Of course, runZero does that too. And lastly, you need a list of usernames to try for those particular key values because the key is only set up for particular usernames. So you want to typically try the common usernames for cloud environment images like EC2 user, Ubuntu, root, of course, and then any particular user-specific target name. So whatever their handle is, email prefix. Oftentimes people will have their username in the OpenSH key comment, and that gets passed all the way through GitHub and back to you. So if you look at the comment inside the key itself, you know what username is probably default for their machine because that's created when you create the key. So you put all these three things together, and now you've got two techniques you can do. You can take a single key and try to get to a whole bunch of computers at once. And that's really, really fast. You can do the whole internet, a few hours pretty quickly for a single key. Now, if you want to do that without false positives, it's a lot more work and requires a few more steps. But in general, it's straightforward. Now, if you want to go the other direction now, what if we wanted to say for a single computer on the internet, who has access to it? How do we take like the entire GitHub 117 million user database and then try to see which username has access to that particular machine? And this is helpful not just in an internet context. If you're on an internal network, you're trying to figure out what developer has access to your internal machine. Well, you just try their key and see which one works, right? You can quickly figure out, does my tenable scanning credential have access to this particular computer while only having the public key for your tenable scanner. Same thing works for a particular developer or service, things like that. So these techniques work not just for doxing people, but also for figuring out whether a credential is valid for a given test case internally or externally. The reason why you can't really test a lot of keys on one server, though, is that you run into these kind of brute force limits in the SSH implementations, whether it's Dropday or OpenSH, et cetera. And that's usually limited by this thing called max auth tries, which is how many times you can attempt to authenticate per connection. And keeping in mind that the SSH servers typically have a maximum connection count. So your maximum throughput is limited to number of connections at a time, times how many attempts per connection, times whatever delay mechanisms are in place that make it difficult to go faster than that. So if you ever had more than 4 SSH keys in your SSH agent and you tried to SSH to any OpenSH machine, you often get like a max attempted disconnect. Effectively, just trying to connect to that server, it's sending all of your pub keys to it, and each of those pub keys you send is being treated like a bad key, and that's being considered as a failed authentication technique or attempt. However, not all servers consider pub key test as a failed auth attempt. About 10% of all the servers on the internet don't. So, for example, drop error, which is the second most common SSH daemon out there, it doesn't care how many times you test the same pub key. It won't count that as a failed auth attempt. So you can take the entire 117 million user GitHub database of SSH keys and just grind an SSH server that's running one of these services, drop error, one of these other ones, and you'll never get disconnected. And you can make as many connections as the server allows. So in practice, that means you can go really, really fast. You can take, in this case, the 4.6 million GitHub dump from 2018, run that through a Dropper server in about 7 minutes or 8 minutes here, and figure out which of these users in GitHub have access to that server. So kind of a really neat technique for figuring out which user has access to what machine if if the machine accepts unlimited pub key attempts. And this is still true today. Like Dropbear and these other daemons don't limit pub key attempts. Now, if we take that and apply that attack to an OpenSH server, by contrast, it takes about 10 hours for the same thing. Now, granted, 10 hours isn't forever, but it's going to take you a lot longer to go through the same list of targets. But keep in mind, each of these timers here are just for a single connection. So if your typical SSH daemon supports, 10 concurrent connections, your 10 hours is now 1 hour. Going back to drop error, your 10 minutes becomes 1 minute, right? So it becomes really, really fast to enumerate keys on not just one server, but maybe many servers with a large key database. And again, that helps you figure out which users access to what machine, but also what service has access to what machine. You can verify, ownership, things like that. So neat technique. That was kind of one of the neat things we first built into the Shamble code as part of the authentication testing. But of course, there's lots more to it. So that hand off to Rob to talk about dropping out shells.
Shaking out shells is I just love the sibilance, shaking out shells. So as HD was saying, there is a lot of broken SSH on the internet. There were about 27 million IPv4 addresses out there with that are listening on port 22, and about 14 million of them will negotiate SSH auth, and about 110,000 of them will open a session. And what's interesting about opening the session there is that there's a large number of systems that will do SSH auth none. And so auth none, as the name implies, is you don't require any authentication. It will open up an SSH session and drop you into whatever happens next. That's interesting because the post authentication, the pre-authentication attack surface of SSH is extremely well vetted and audited, and there's been a huge amount of thought put into it. But the post authentication attack surface, I mean, it's kind of assumed that once you're in, you're supposed to be there. So there's a lot more that's available to be poked at and prodded. You can send exec messages, you can send signals, you can invoke subsystems, the SIG-winch to say that your window size changed. All these things will be conveyed to whatever is listening inside that session. And what we found is that there was a lot of post authentication. So you'll SSH in, and you can get it with an empty password, or you can get in with just SSH auth none, and then it will take you to a separate system, not a shell, but a separate program running inside that SSH session that will ask you to authenticate, ask you for a username, ask you for a password, things like that. And once you're in that environment, the doors are a lot more open for the things you can do. For example, you can HD inject signals. So I'm gonna let HD talk about signal injection.
One of the really fun things about these post-auth login mechanisms, where the server technically logs you in on the SSH side, but then it gives you another authentication prompt, is that there's a lot of things you can do, as Rob mentioned, to the session, including sending arbitrary signals to it. Now, in the case of OpenSH, there's only about 8 or 9 signals you can send that are considered safe. So you can send like a SIG hub, SIG winch, things like that, to indicate to the sub process that things are happening. But other SSH implementations like Dropbear that allow you to send anything at all. So for example, you can just send a random SegV to a login process and cause it to core dump. And there's this one particular product we run into has a really funny message. It has like a SIG-SegV signal handler. And if you get to the login prompt and you pop open the Shamble interactive shell and say, send a SegV, it goes, "Aye, seg fault." And it's really funny. So, but there's probably a lot of attack surface there. If you think about like the regression vulnerability in SSH, where it was re-entrance of a signal handler, you can set signals all day long. You can mash signals all day long into these sessions because you're already in that post authentication state. So now you're able to attack signal handlers within the sub process, not even SSH itself. So it's a really dangerous place to be where you've got an authentication process that's allowed through SSH and now allows environment control, signal control, things like that. And with that, back to Rob.
Yeah, POSIX is if you ever read the documentation on POSIX signal handling, it basically it's very difficult to do correctly, and I think a lot of people think they're doing it correctly, and they're not. And yeah, but another thing that's exposed in this post authentication world is SSH forwarding. So SSH allows you to build virtual tunnels, virtual connections, virtual circuits, so that you can create almost your own little VPN. It's very useful and very easy to set up, honestly. And these channels can forward all sorts of things. They can forward shell connections. They can forward X11 connections. They can run specific programs that are specific subsystems, things like that. And they can also forward to third-party machines. You can actually set up a tunnel through an SSH server to a third system. And a lot of times, these things are prevented, more or less correctly, but a lot of times they're not. You can, yes, SSH connection forwarding is the best kept secret. And it will so what we found is you can oftentimes forward from your system either back to the system on a different port. So you can use that to bypass firewall restrictions, or you can actually just create a connection through the system to something on the inside. And you can see here, this is an Ion Networks service access point, and we're running through SSHamble here. And so you can see that we're trying to create a TCP tunnel to www.google.com, and that doesn't work. But you can see here, and we can't get to 8.8.8.8, but we can get back to the local host. So it does actually let us bypass potential firewall protections and things like that there, which is pretty fascinating, and something that I think a lot of people don't necessarily think about when they're setting this sort of thing up. But another thing you can do is shell injection, and I'm going to split back to HD to talk about that wonderful, wonderful process.
Cool. Thanks, Rob. So quickly on the forwarding side, we've seen systems that have like a Redis daemon bound to loop back with no authentication.
Mm-hmm.
And so you can basically use the port forwarding pre-login to get access to Redis to dump their credentials to then log in. So it's a fun full circle on that. But something else you can do that's kind of fun is some of these processes that are interactive login prompts have standard boring meta character injection bugs, like stuff that you would have seen in the 1990s that should be fixed by now, except for no one's bothered testing it because it's hidden behind an SSH server. And so we find a lot of oddball bugs out there that really shouldn't exist anymore. That really, bugs that like would not have survived the light of the day if they were on a telnet port instead. So there's a particular product, the Ruckus Wireless APs. They've been bought, so under a different name now. These access points running versions 520 and 620 and below for each of the firmware variants. The password that you type into the login prompt is actually put into an echo command and then passed to SHA-256 to get the hash of the password. But they put it in double quotes, not single quotes. So of course that means you can just put dollar parentheses, whatever you want into it, redirect that to standard error, and effectively run commands as root pre-authentication on these Ruckus APs. Now it's kind of a silly bug. It's not super important, but for some reason there's still 900 exposed on the internet. Out of like 36,000 Ruckus APs, there's still a pretty big portion of internet-facing ones are exposed. And the reason, of course, is there was no CVE, there's no security mentioned in the release notes. It was technically patched, but no one told anyone about it. So no one realized they had to apply the patch for it. One of my friends at Sprocket Security recently did a test with their own customers and said, let's take SSHamble and look for this stuff. And they found exploitable Ruckus APs internally. It's just one of those things where because the vendor didn't provide any notice to customers that there was a security bug being fixed, no one applied the fix. And now you've got a lot of stuff being exploited. So it's just one of those things where, it's really important to tell people when you fix a security bug. Otherwise, you end up in situations like this where folks are, inadvertently exposed and don't realize it. And of course, this is now a legacy product. So kind of quick demo with
I see the issue. They're not salting their hashes. No.
Yeah, so you can see here, we did the SSH command, and SSH command let us get past authentication with auth none. Now we're into the post-auth authentication. And we're able to type a PS command inside of the password field and immediately get a process listing. And here you can see the Ruckus command line process, which is RKS CLI. The really fun thing about this bug, too, is that even if you had root access to the Ruckus, it would only put you in a restricted shell. So you actually have better access to the system through this bug than you do even with valid credentials, which is a little bit ironic. Cool. And with that, back to Rob to talk about environment.
So SSH, is the secure shell. It was designed to be a replacement for the older remote shell protocols like RSH and Telnet and things like that. And so one of the things it lets you do is pass environment variables up to the remote process. And environment variables are, set to set useful things like, oh, this is my terminal emulator, type and my prompt and things like that. And something that we noticed, and I promise this will tie together, is that there's also recently been a renaissance in Git-based code forges. So things like GitHub and GitLab and Bitbucket, but then also self-hosted ones like Gogs and Gitty and Forjeho or Forejo or however you say it, Garrett. And these all accept SSH. Git can be used over SSH, and these accept SSH, and that's great. And they also tend to use these embedded SSH libraries that implement the SSH protocol. And so they'll let you send up environment variables via these SSH implementations, and then usually it's up to the client of the library, the actual software that's using the SSH library, to filter out the environment variables. Most of them do a pretty good job. GitLab, Gitty, and Forjeho do filter out most environment variables, but they don't filter out Git protocol, which is intended because that is actually sent by Git to say, oh, I'm going to use protocol version 2 or whatever. And that seems to be relatively secure, but there are some issues there with, for example, Go. If your GitForge was compiled with Go earlier than 1.19.3, you can do environment variable injection by putting a null byte in the value of the environment variable, and then you can put a new environment variable in there. So that's one sort of way to smuggle something in. There was also a vulnerability in Gogs, which was interesting in that we discovered this, and then HD, what was the disclosure timeline, discovery timeline?
I think we reported it April 24th. Then we found out Sonar Source reported April 22nd. So 90
Yep.
days afterwards, they wrote the blog post on it, which is great. So it's always
Yep.
wild that there's like concurrent discovery of the same vulnerabilities that close together with no
Mhm.
coordination.
And so what Gogs does is it invokes the standard command env, which sets up a new environment and whatever, but it doesn't sanitize the output, and it doesn't even actually invoke it in such a way that it's useful. It doesn't actually set the environment variable in the process that's going to get run. So this is a pretty trivial vulnerability, backdoor, however you want to think about it. And Gogs there's no patch available for this. So I would suggest if you're using Gogs to consider perhaps using something else if you can. So going back, these libraries that implement SSH, because they're designed to be general purpose, they will accept any environment variables. And then, like I said, it's up to the client. So Apache Mina is a Java implementation of SSH, and it will, not surprisingly, accept any environment variables that you pass up. But at least, for example, like Garrett, which is a Java Git Forge management thing, it does filter out environment variables, which is good. And then JGit doesn't spawn subprocesses, so there's no real chance for that to impact much. But there is one, and this was a lot of fun. There's something called SoftServe, which is a really pretty, and I mean that literally, like it's a very pretty interface, really well done, that lets you set up Git forges very quickly and very, very simply. And it lets you then use SSH to push code and pull code and whatever. And it was not filtering the environment variables that were being passed to the Git subprocesses when it invoked Git. And so we got a CVE out of this, and this was great. And we have a quick little demo here where you can see how slow a typist I am in GIF form. But you can create some shellcode, and then you can toss it in. And there's other ways of getting to this. You don't have to use Git LFS, and you can do it in various other ways. But this was the fastest way because LFS has predictable file names on the server and stuff like that. So you can see here we push the shellcode up, and you can see that we take the SHA-256 sum of the shellcode because that is going to map to the path on the server. And then we can just pass the LD preload variable and say preload that code to soft serve, and it will preload that code, and there's your shell. Voila, soft served up to you on a silver platter, as it were. That has been fixed, and the folks that we worked with, they were super nice. So, but that was a lot of fun to discover. I always like finding stuff like that. And so now moving on to broken states, the state machine of SSH with HD.
Cool, thanks. And let's see if we can go forward. So SSH has a pretty complicated state machine. There's various fixed windows of what you're allowed to do as you go through the authentication and other parts of the process. So when you first connect to the TCP port, you're allowed to get the server version, send the client version, do the key exchange. Then you trigger the kex init, the whole Diffie-Hellman or similar key exchange process, resulting in an encrypted transport. Then you actually start doing things like authenticate. Like, oh, I want to authenticate as this thing with this method. It verifies you. Eventually, it says yes, you're authenticated, and then you're kind of in this weird limbo state where you're authenticated, but you haven't really requested a channel yet. And a channel really is what you normally think of as your session, your port forward, your X11. So if you've gotten to the process of authenticating, we haven't opened a channel. It's called the larval session state. It's what most of the SSH implementations call this. You'll notice here on the left side that the individual message IDs that are allowed for a given state are kind of clamped between a given range. So not only is the code really good about saying, I will not accept a message outside of this range of IDs for this given state, but both OpenSH and Dropware have a command handler table of functions, and they're actually rewriting that function table as you iterate through the state. So even if you get something wrong, there's no function pointer to call. Basically, you end up calling the default handler instead, which triggers an error, as opposed to calling like, the shell handler instead. So because the SSH state engine is so important, the two biggest implementations here have been really careful about allowing you to iterate through states when you haven't completed authentication. But of course, you can see that for things like post auth authentication, where you've got auth equal none, and you do something else beyond that, like you've already kind of bypassed most of the guardrails in SSH that prevent bad things from happening. And you're kind of down here in the murky land of larval session states where things get a little weird. So the session state stuff is pretty important, and it can get wrong pretty quickly. So back in 2018, there's a vulnerability in a library called libSSH, which is pretty popular with C-based applications that want to talk SSH that are not OpenSH because it's much bigger and heavier. Where because these SSH libraries are typically used for both the server and the client, in this case, the server trusted a authentication succeeded message, even though it wasn't sent by itself. So a client would say, "Oh, I'm authenticated," and the server said, "Cool, you're in," and that's it. So it was a really neat bug. There's a Metasploit module for it, and we thought it'd be neat to take that same approach, but to go a little more in depth. And so in this case, the session bypass, if you will, was by sending this unexpected auth success message in the middle of the handshake. We decided to go through and try to ask for a shell in every single stage of the protocol. So everything kind of like after the key exchange, all the way through up to pre-authentication. Say, how about give me a shell now? How about now? How about now? How about now? And then see what popped out at the end of it. And so that was a fun process, and we found a bunch of stuff. So there's these fun little ICS routers by Digi International called Transport WR gateways. There's an uninitialized variable in the process where if nobody else had successfully authenticated to it since the last reboot, you can get a remote shell as super pre-authenticated just by asking for a shell prior to completing the authentication process. And it was kind of random and really difficult to troubleshoot because it's based on the uninitialized value of a variable. So sometimes it was flipped to not zero, sometimes it was incredibly difficult to debug. And the Digi International team was really great at both helping track down the bug, get a fix out, but also helping us fix our scanning code to identify odd behavior on that side too. So a great relationship with those folks. Less great were some of these other products that we ran across. Like there's a category of Realtek SDK based routers where we can never really figure out who the real manufacturer was. We saw the SDK, we see firmware versions as late as 2023, and it's straight auth bypass. Like you literally just skip SSH user auth and you have a shell. And it applies to Netish routers, which are really popular in Iran and Egypt. Neterbit routers, which are popular in Iran and Egypt. Netish routers, which are all over the place, APAC, Middle East. And we really couldn't figure out who to report it to because every place we emailed saying, hey, how like the Netish people, for example, or the Neterbit folks, just emails all bounced, and then we didn't get a response from the forums. So these are all still wildly exploitable and all over the place. And then similarly, we found a weird subset of Panasonic Ethernet switches where it would just drop Unos admin and bypass auth entirely. But again, it was really difficult to figure out exactly what versions were being affected. And for these particular devices, all the documentation was only in Japanese. So we're still kind of tracking down who and how to report it and trying to get hold of the right people for it. But again, these are also 0-day, unfortunately. So a quick example of what like the Neterbit or Realtek type router bypass looks like. You run Shamble with the scan option until it's interact with the first session. And it's going to go through and connect to it and then start trying to basically brute force different ways to get a session in between. Here you can see like the very first thing we tried, which is without even sending the user auth start command, we're able to drop straight into a command shell. And in this case, we were first getting to the Shamble shell, and now we can show the full stats and firmware versions, things like that of the device. And here's an example of the same thing, but for the Digi International transport routers. Kind of similar process, except for we land on a different state injection. In this case, we're dropped directly into the shell and says, "Welcome, your access level is super," which is great. So I love the super. Yeah, so there's some fun bugs in the state engine. There's probably a lot more out there. We have another giant pile of bugs that we haven't quite classified yet, like where you get a session, but it doesn't seem to be exploitable. A good example of that would be net screens. So a net screen device, for example, you can connect to, it'll give you a session, but you can't really do anything with the session. And we know there's probably something you can do with the session. We just haven't figured out how to like get a shell out of it yet. So there's a large category of devices that have these kind of session bypass bugs, but don't really lead to a way that's obviously exploitable yet. And we're still digging into those. So that one, take a quick detour and talk about the OpenSSH ecosystem. Um, Typically, when you talk about SSH, you're usually referring to OpenSSH. OpenSSH was derived from OSSH, which was derived from the original free version of the SSH protocol um, from way back in the mid '90s. However, OpenSSH is no longer just OpenSSH. So every operating system packages it slightly differently, has their own set of packages. So we went through and did the somewhat long and painful process of taking the diffs of every single OS versus the OpenSSH portable patches and just reading all hundreds of files and trying to figure out what did they do to poor OpenSSH and what did they break. So good news is macOS was the lightest touch. They barely touched the core OpenSSH code. There's compatibility support for things like keychain, PKCS helper, endpoint event logging, but beyond that, it's pretty much bone stock, which is great. So it was nice to see that macOS didn't really mutilate the code too much. Once you start getting into Debian and Ubuntu, you're about 36 different patches. It includes things like the systemd patch that made it XE backdoor compatible. Same thing with Red Hat, except for the Red Hat patch count was closer to 60, so even more code changes versus like upstream OpenSSH. And of course, the more stuff you change, the less likely is you're going to find all the bugs. And so in general, there's a little more risk, kind of the more that's being changed. There's also a product called PKIX SSH or project. This was forked from OpenSSH way back in 2002 to support X509 certs, and it's really commonly found in networking gear that needed to be FIPS compliant to sell to federal government. And it kind of sort of follows OpenSSH changes, like they weren't really line for line compatible, but they try to follow along the overall stuff. So they were also affected by the regression vulnerability, but in a slightly different way. And we found some cases where it looked like they're trying to mirror the changes to OpenSSH, but then the booleans were wrong. So instead of a if a equals zeros and if a not equals zero, things like that. So there still seems to be some work to be done to figure out are there any of the differences between PKIX versus OpenSSH actually exploitable or problematic. But none of these are anywhere near as bad as what we found with Windows. So I was very excited to find out that Microsoft Windows ships with SSH by default in Windows 10. I'm like, okay, I don't have to install OpenSSH in every single Windows machine I get. This is great, including when you compromise one and want to use it. You can now shell back out again, which is great. There's also an OpenSSH server that's part of Windows. So it's actually a component. You go to programs and features, you have the server feature, and hooray, you've got OpenSSH server on your server, your Windows server, and you can log into it and do all the fun things, which is great. When you start looking into how they actually did the change, though, they ripped out so much stuff that it doesn't really resemble OpenSSH in a lot of ways, especially not when it comes to security. So it replaces fork with subprocesses because you don't have fork on Windows. It gets rid of the true root support. Some of the log sanitization to remove kind of bad byte characters from the log sequences are pulled out because logging now goes to the Windows event log instead of going to a local file. It also sends telemetry back to Microsoft for all kinds of stuff, including encrypted values that are sent over the SSH transport, which doesn't seem particularly great. All the password authentication now uses the LSA functions, and it still doesn't fix Terrapin. It wasn't affected by regression, though, because there was no signal reentrance. So, there's that at least. But going to OpenStage for Windows a little bit here, probably the thing that a lot of folks were going to be less comfortable about is the fact that the telemetry code in OpenStage for Windows literally sends all your stuff up. Like it doesn't send your actual like password, it doesn't send your SSH session communication, but it sends almost everything else. So which authentication methods you tried, the version of your server, the version of your client. So effectively, if you're running an OpenSH server in your network, every time any other client connects to it, including like your vuln scanner, the client version is being sent back up to Microsoft as well as your server version. So, they know when you scan your server with Nessus, they know when you SSH from a Mac, they know when you SSH from a Linux machine, they know when you scan it with another SSH tool. So in general, there's a lot of kind of, really sensitive telemetry getting sent back up the chain here that a lot of folks probably would prefer did not happen. Now, the good news is because it's baked into the standard telemetry backend of Windows, running like the shutup O++ tool or other tools that disable telemetry also disable this. So if you are concerned about it, just turn off overall telemetry on your Windows machine, and it helps with this too. The one that really took the cake, though, is there's a function in OpenSH that's probably the most critical security function in the entire code base. It's this really tiny, maybe 3 lines of code if you don't include the variable declaration in the return here. Written by DJM, who's one of the main authors of OpenSH. It's timing safe, it's efficient, it's secure, and it's designed to take 2 binary buffers and see, do these 2 binary buffers match exactly? And they do, and can you compare them in a way that doesn't leak timing information back to an attacker? So it's very common in cryptographic operations to do a timing safe byte comparison. And this is great. It's good code. Nothing wrong. It's perfect. But then Windows decided to make it Windows compatible. So this code that used to be pretty straightforward and simple now actually checks for backr backend sequence for I'm not sure what reason. As far as we can tell, the developers were using the OpenSH for Windows developers were using this function to parse a configuration file. And of course, Windows configuration files typically have CRLF sequences, not just line feeds. And so as a result, they added this check into this crypto function instead of the right place for it. So this thing went from being very secure, very tiny, to no longer being timing safe, to having a 1 byte out of bounds memory read per backr sequence in the source buffer, and it does an unequal byte matching. So it no longer actually measures whether 2 crypto buffers are the same anymore because you can cause it to read outside the bounds and skip ahead of bytes. So somehow these 2 lines of code backdoored these 4 lines of code in a way that just made it really, really dangerous. So we started digging into it. Like, what does it actually affect? Well, it ends up like every single SH packet has the MAC check being done by this function. So literally every packet goes through this filter that is now CRLF compatible. And that's just about everything else important too. RSA signature verification, X11 cookie comparison, the cha-cha poly MAC stuff, all kinds of stuff. So it was really, really gnarly looking, but is it exploitable? So because of the way the buffer works, the attacker typically only controls the second buffer that's being compared, not the first buffer. And the only real way to get data that triggers this bug into that first buffer is just to brute force crypto operations so you happen to get lucky and get a backr backend sequence. And a single backr backend isn't really particularly exploitable. You really need more than one. And so now you're looking at like a 4 billion, rounds of requests to hopefully land in that particular random sequence. So not super exploitable, but of course, we reported up to Microsoft where they invest more than $1 billion annually in cybersecurity and research development, have over 3,500 security experts. And they said, we're not going to fix it. Or effectively, we're not going to care about fixing it. So thanks. So it's a shame that they didn't think it was more important to service. The good news is I got in touch with the OpenStage for Windows team. They've got a PR open for it. They haven't done a build for it yet, but they also still haven't fixed Terrapin. So at least it's fixed in the source code. But it's kind of a shame that it wasn't treated more seriously. So with that, I want to switch gears a little bit and talk about the tool we built for all this stuff. It started off being kind of that half-off Pug-C scanner, and then it turned into kind of an everything else tool. So we really look at this tool as being both a research tool for finding new bugs, for testing out your own SSH implementation, for poking out like a vendor-provided appliance that has restricted shells, things like that, but also a way that you can quickly sweep your own networks looking for things that they're buggy. So like I mentioned, my friend over at Sprocket Security, they ran a bunch of scans and they found some Ruckus devices affected. They also found devices with port 40 enabled pre-authentication. So who knows what you're going to find, right? So it's a great tool to kind of throw out your older, jankier devices or weird vendor restricted state sessions and figure out what do they get wrong. Because it lets you test a lot of things. It lets you test for post-auth attacks, pre-authentication state transitions, post-session enumeration. There's even some timing analysis code in it to see whether the device leaks user whether you can brute force to detect a username based on the timing it takes to confirm it, either pub key or password auth, with some neat like, stats code around it. So you can grab that from shamble.com with 2 S's, and that takes you to our landing page, which has like GitHub links, things like that. So there's a whole bunch of checks baked into it today. There's the auth bypass, public key, password stuff. Rob, do you want to talk about some of the vuln checks?
The vuln checks, yeah, are a lot of fun. They're my personal favorites. So we can, as we discussed earlier, this will check to see if you can do TCP forwarding. It will check for the GOGS vulnerability. It will check for the Ruckus password command injection vulnerability. The soft serve, the specific vulnerability with environment variables that touch soft serve, and then also the generic environment variable issue where it will actually try to set generic environment variables and see how it can influence the execution of whatever gets run on the other side. And spoiler alert, there's sometimes a surprising amount that you can get in there with things like if you can control LD preload, which is the one of the variables that controls how binaries are loaded on Linux and BSD and Unix systems. Super, super fun. And so I recommend, pointing Shamble at any SSH that you have permission to scan and scan it.
That's a good note. So we work on runZero all day long here too, and we didn't necessarily want to take all the things we do in Shamble and throw it into runZero because it would not be very nice to most devices, right? It's not designed to be a friendly scanner. It's designed to find all the bugs. So it's kind of a definition between like what we normally do with light network discovery and passive discovery and integration discovery versus something like this, which is much more of kind of a brute force heavy vulnerability discovery tool. So some stuff like the better SSH auth none and some other types of authentication enumeration are all built into runZero now. For example, we now enumerate all the different SSH host keys, not just the default one, which is pretty unique out there. Most folks only retrieve the first key. So we retrieve all the keys. We store all kinds of other fun information about things like session extensions, but we don't go through and test this entire matrix of vulnerabilities because it would not make your routers and servers and switches happy. So if you want to get started, you can grab the binaries and the source code from GitHub link. You can do just a go install. You can put in a Docker container, whatever you like. It's got two commands: scan and analyze. Scan kind of does what you think it does. You give it an output file that's just JSON. You give it an IP range or ports, and it just goes out and tries all the default attacks against all the things. And you control exactly which checks are being run. You can also then use the analyze command to take that resulting file and kind of bucket it by known results. So any kind of things like known honeypot, stuff like that will automatically scrape out based on fingerprints and signatures and put into a different file. So you can kind of skim through the results and find things that are interesting in your environment. And there's tons of configurability. You can give it like a list of usernames, passwords. You can even do like a boring old like username password brute force with Shamble if you want to. It supports that too while you're at it. But it also the neat thing about this, it'll use all those usernames to then try the session auth bypass, the pub key testing. Like you get all the functionality of all the auth bypasses with this customization too. Some of the password checks are pretty cool too. It'll try to send like a null password. One thing that was really funny / terrible is that when we first started testing out the ability to bypass authentication through a password change command. Effectively, it's like a password auth command, but you send another parameter saying, here's the new password. It unfortunately worked. And of course, we were using a random password for it. So we don't know what the password's set to anymore. When we ran that, it's like, well, that's probably not a good thing. So we had to reorder things a little bit, do a null byte first, things like that. So yeah, and lastly, there's an interactive shell built into Shamble. It's pretty cool. So normally when you get a SSH shell, you go straight into your prompt and do your stuff. You can actually tell Shamble to interact with nothing. So interact with the first shell and set interact auto to be an empty string, and it will do absolutely nothing. It'll give you that larval shell, and you can now do things like set environment variables, request PTYs, do port forwarding, even before asking for your first shell subprocess. What we found is some devices would only really restrict the security of the shell when you ask for a process like a subshell. So you can do a port forwarding even as long as you haven't requested a shell yet. So you find these kind of like weird interstitial bugs because of that. And of course, you've got a long series of like session breakout, signal pounding, whatever you want to do stuff. All the normal interaction or interact command line options you can put into the interact auto field. In this case, we're going to tell it to request a PTY, set the LD debug all variable, and then request a shell. All is a one shot against the server and make it really quick to test out, kind of a macro, if you will, of the Shamble test on a given machine. And the shell itself looks like this. You've got a bunch of commands. You can send raw bytes. You can send them one byte at a time. Funny enough, one of the reasons why a lot of these bugs haven't been discovered in the past, especially like things like the Ruckus bug, is that if you connect to the SSH server with Ruckus and you just like pipe in a long string of input, they just do like a straight standard in flood of all your requests of like the password injection, it doesn't work. Like you do not trigger the bug. And the reason for that is it takes a little while for the sub process to actually spin up and start reading input. And so until you actually get to the point of the process being ready, it actually just drains standard into dev null. You really get no input done. So in that case, for the Ruckus bug, we have to send the input to it one byte at a time. Otherwise, you can't exploit the bug. So it's little things like that that make some of the vuln discovery of these things more difficult, and some of the reasons why they probably weren't found prior to us looking at it. But the best part about this, it's all open source under kind of the standard, I think like 2-clause BSD or something like that, as open as it gets. So if you've got cool things you find, test you want to add, please go for it. We have already got like 6 or 7 pull requests since we opened the project after DEF CON. And since then, we've been doing a few updates to it. We now auto-build release binaries and versioning. We added kind of experimental support for HanoBox bad keys project, which when you run the analyze command with experimental flag compiled in, it'll actually tell you whether any of the keys, host keys of the systems you scanned are known to be compromised keys. And Rial Sloan too provided a PR for container support if you want to run that on Docker instead. Yeah, you can get it from shamble.com. And with that, I'm going to switch over a little bit and talk about some more product stuff and some rapid responses. So happy scanning on that front. And actually, sorry, before we got there, Rob, do you want to jump through the exposure metrics?
Sure, just real fast. So as we discussed, there's a lot of these systems out on the internet that we found using throughout this entire investigatory process. And it was pretty interesting. This is just reiterating the vulnerabilities that we were aware of and just how how severe they are. And we found that there were tons of these systems out there. We also found tons of duplicate host keys, which was sort of interesting in that these are supposed to be unique per device, and they are not. We actually found millions and millions of devices with these the same host key burned in. Oftentimes, uh, networking equipment or built gold images for virtual machines, all sorts of interesting things that are extremely highly duplicated. We also found, so here just in an example of the 100,000 hosts that we found with none authentication. So we found 36,000 Ruckus access points, 16,000 Sonic firewalls, about 5,000 honeypots, which that's not surprising. 1,300, I'm going to say Ethra gateways, and 1,100 Huawei gateways. So tons and tons and tons of systems out there that will let you get in with none authentication. And then we even sampled just a few systems that we were able to see in some internal data, and we found some wireless access points and some HP switches, and the Visual Studio Team Foundation server, which is fun because it's got a really interesting banner that pops up that is always nice to see. So lots of non-authentication out there. And I wanted to move on real fast to Blaine, let's say rapidly to Blaine, to talk about rapid responses. So, Blaine, take it away.
Yeah, we got a handful of responses this month. Sort of like to kick this off, we have these Mobix IP cameras that are sitting out there that somehow have TCP dump running on them, and they will not validate input. So remotely, you can actually start to send stuff to that TCP dump process and eventually get some RCEs out of that, which is fairly interesting there. Not sure why you would need sort of TCP dump stuff on your actual IP camera, but hey, why not? And of course, we have some OT devices from Siemens. This one has a plethora of CVEs, sort of ranging from a lot of input validation on VPN configs. Some of them are doing like session isolation problems where you could sort of like swap between sessions to sort of get privilege escalation if you can trick your way through that. MFA tokens getting logged through log files and sort of sitting on disk, so you can sort of poke your way through those and grab some MFA tokens in the process. And a good old large input DOS attempts to just flood the thing until it crashes and you have to go and restart them. Yeah. And then, sort of in a similar vein, we got Rockwell coming back around again with a few of them. Most of these are sort of surrounding the management packets for a lot of these devices that they have on the list here. So as soon as you start to malform these packets to sort of probe and get information from them, you can just basically take them out and require them to be restarted, which is, not surprising all that, because they're sort of expecting a lot of these devices to be on closed networks and not have like public access to them. So, and given that they are, on the OT side, even though they are management, they sort of like push validation to the side and just like, don't worry about it kind of stuff. The next one we have up, the desktop licensing. I think that was the one for, yeah, they had an unauthenticated message where you could sort of trigger another remote code execution as well. So I think the fix there was basically just to turn that off if you don't need it. But again, another that was a little bit more, open because it is a standard management service, but having something on unauthenticated sort of accept that traffic was an interesting choice. On the Versa Director side, so they sort of sell like these network switches and management and VPNs and firewalls and things like that, and they have a portion in the GUI console to customize your UI based on how you want to see it. So you can put your logo, your fav icon, and other sort of stuff. Which, if you specially craft a really nice fav icon, that might be a ping, but sort of sneak in some extra code in there, you could get yourself another RCE. So I feel like we have a trend of RCEs this week. This sort of start taking over everything.
But that Versa Director vulnerability, that's being actively exploited in the wild by some threat actors, Volt Typhoon, that are potentially linked to the Chinese government.
Yep. Yeah, we covered a lot of that stuff on the blog post itself. So if you want any more
Mhm.
information there, like definitely pull it up and make sure you close that door. Um, yeah, and the last one is another interesting one. They sort of came back around. I think it started with the IPv4 version of this in Windows in the stack. So sort of dig into what this is actually doing is in order to sort of get some performance out of packet processing, Windows will start to sort of coalesce these packet headers together and sort of like run through them and parse them. But if you end up causing if there's a parsing error in one of those packets, it'll reset the buffer to 0 and flag the error during this IP send error function when it's sort of running through just the headers of the packet itself. But it won't stop the processing of the rest of the packets in line. So if you hit a malformed header in one, the others sort of still get concatenated together, and then eventually, with a certain sequence of input from the later fragments, you can actually start to cause integer overflows because of the 32-bit sizes that are there, and then you can end up sort of crashing the system or getting like heap overflows because of the integer sizes coming over across the wire. So um, HD ended up finding a cool little proof of concept in that repo down at the bottom. So again, there's a nice little video to sort of explore it. But when you open up the Python file to sort of see how relatively straightforward it is to just exploit this, it's pretty clever and pretty interesting. So yeah, that's that general roundup for this month. Is feels like it's an RCE month with a little bit of a buffer overflows in your IPv4, IPv6 packets.
Yep. Everything old is new again. It reminds me all these
Yeah.
remote server and client. It's for so long I felt like it was this huge client side focus, and now it's server side is coming back into vogue.
Yeah.
And
I
so
sort
with
of
rapid response,
yeah.
hmm?
Yeah, I sort of understand the OT side, but one of my
Mhm.
favorite one was definitely the TCP dump sitting on your IP cameras.
Yep,
Yeah.
yep, I love it. Those were the whole TCP dump and all of the X11 games were sitting on. I think it was might have been F5 load balancers way back in the day. It was something. No, it was a firewall that was running just BSD, and it had everything, including X, on your firewall, which I loved.
Nice,
Um,
perfect.
so with rapid response, do be sure to check out our blog posts and read them. We give you queries on how to find these vulnerable devices on your network using runZero, and it's usually pretty simple and pretty quick. And with that, let me toss it back to HD to discuss some recent updates in runZero.
Sure, thanks. Yeah, I'd just like to share kind of what we've been working on with the teams here. If you've used our layer 2 report in the past, the new version looks a lot spiffier. So new icons, new links, better searching, keyword, autocompletes, things like that. So you can also change it from the kind of network layout here to more of like a hierarchical layout as well. So you've got a few different ways to kind of look at your layer 2 infrastructure and get a better feel for how your stuff is wired up. Separately, we've added a bunch of new support for end-of-life tracking. So things like Cisco IOS XE, IBM AIX, Juniper JuneOS, Palo Alto's PanOS. We now track the end of life in those versions and tell you when they're beyond or when they're going to expire. We also exposed the new extended end of life status for things like LTSC versions through a new system query. And of course, you can also turn that column on in your inventory as well if you want to see the extended end of life if you have an extended support contract with Microsoft or one of these other vendors. Separately, we've added support for identifying client-side software better in the passive traffic sampling code. So, typically if you're running, scans with runZero would identify a lot of stuff server side, but if you're running the passive code, the passive sampling task in runZero, we can now tell you like which AVs installed, things like that. So this is kind of the beginning of that effort of identifying EDRs and AVs first, and we're going to continue that process to support a much wider range of software going forward. A bunch of miscellaneous updates. The team's been really focused on making the performance and accuracy of asset correlation emerging just like amazing. So we've gone through and kind of rewritten a big chunk of the code and handle things like auto rollups now, cleaning out duplication automatically, and then making everything much, much faster too, especially with really big data sets. A lot of folks don't realize that when you're pulling something in, like let's say you want to take your tenable vulnerability data and bring it into runZero. Well, you may be pulling in literally 80 gigabytes of data for a moderate sized organization. There's a lot of data that comes into that. So being able to quickly process that, correlate that, merge that in, and figure out how it's relevant to your stuff is really important. And you have to be, really fast to doing that to make it worthwhile. Otherwise, you're waiting too long to be able to use the data effectively. For folks who are based in the EU region, we now have a European SaaS option. So just contact your account manager and they give you a sign up link for it. It's based in Germany, and all the data stays in Germany, which is a nice thing. Just like all of our US data stays in the US, we've got the same option now for Germany. If you're using the self-hosted version of runZero, there's a lot of configurability. You can now tell what directory to install in. You can override more parameters. You can automatically specify the temp directory being used during the installation process. Generally, just to make it a little more easier to use for constrained systems. Our designer has gone on a tear of replacing vendor icons to the whole product to make them shiny and nice. So if you haven't looked at the runZero inventory in a while, you'll see it'll be a lot more colorful and a lot more recognizable vendors. The first range of, I think, about 70-ish icons went out last week. We've got another big bucket going out this week. And then, of course, the whole research team is always focused on new and improved fingerprints across the board. And, of course, tuning up things like better protocol support, things like that. So just been grinding away on all that stuff. And hopefully you all find it valuable. If you'd like to see the full release notes, the release notes here basically go back to the beginning of time, all the way back to 2019. You really want to follow the links. You can see what we built when runZero was called Rumble and things like that. But you can also find the detailed notes for all the previous releases. Let's see, looking at some of the questions real quick. It's a question about whether runZero scanners will find vulnerable devices. We don't turn on all the Shamble features by default. We do a little bit of the discovery in runZero, but if you enabled everything, it probably wouldn't have a great impact on things like OT and fragile devices. So we recommend running the full Shamble tool against your internal SSH daemons on machines that you feel you're comfortable doing kind of more aggressive testing. It's not any more dangerous than running a vuln management scan, but it is a lot more dangerous than a typical runZero scan that's a lot lighter touch. So we don't want to surprise folks by publishing all your SSH daemons. Cool. Thanks again for joining the webcast today. We do these every month. You can find a link to the next one here. There's a question about whether we're going to integrate the full version of Shamble into runZero. We're talking about it. There may be an option where it's just like an option you flag in the UI saying, yeah, I want to do a full, deep SSH test. We're trying to figure out what that's going to look like. We want to make sure folks don't enable it by accident and cause problems. So, number one goal for us is making sure that it's always safe to run the product in any environment. But of course, we want to allow you to take advantage of all the cool stuff we're doing too. So let's see with that. I think we are on the end of the slide here. You can reach our team, research runZero.com, of course, the website, runZero for anything else, and then Shamble for the Shamble tool. And we're looking forward to continuing to make that tool better and to hopefully see more PRs for the community.
Thank you, everybody, for joining us. That was a lot of fun. If there's any other questions, feel free to toss them into the Q&A real fast here, or you can, like HD said, always just email us at research@runzero.com. We love getting emails. We love hearing from y'all. We love doing research, and so if you tell us to do new things, we always love that because we like to poke at things and see how they break. So thank you so much, everyone. We look forward to seeing you again next month. And until then, please check out Shamble and have a great month.